In this chapter, we turn to the question of why some people make a lot of money and some people don't. And we start with an analysis of labor markets. And sometimes this is obvious. Why does a CEO make more than a custodian? Well, the CEO is highly educated and in charge of making decisions that have consequences that amount to millions and even billions of dollars, and a custodian is feeling thankful for a minimum wage or slightly above minimum wage job. But a lot of times in the economy we see very, very small differences in ability or luck, frankly, translate into huge differences in earnings. And so I have this opening picture here of Mary Lou Retton. This commercial I saw the other day, it was Good Feet or something. Both Mary Lou Retton and Bill Walton, who's also pictured there, have had to retire early because of foot problems. Anyway, Mary Lou Retton, 30 years after her victory at the 1984 Olympics in Los Angeles, is still a bankable star for companies to pay tens of thousands, who knows how much, to each year. Now, arguably, in the 1984 Olympics, a Romanian gymnast by the name of Ekaterina Szabo outperformed Mary Lou Retton. I think Mary Lou Retton won the all-around, but Ekaterina won, like 4 individual events, and the team gold. And anyway, so she had maybe a better Olympics overall, but in this one premier event, Mary Lou Retton edged her by, I don't know, a few hundredths of a point, if that. And where is Ekaterina Szabo now? Actually, even on Wikipedia, and a Google search, I couldn't find much information about even what Ekaterina was doing. She was a coach for a little while in the 80s and 90s and disappeared from the media eye after that, apparently. Maybe she's Hungarian. I think she moved to Hungary, but according to Wikipedia. Anyway, well, let's turn to a little more organized way of looking at things. Why do people earn so much? I didn't mean to draw a line. I meant to turn the page. Well, one reason why people earn a lot, in the text they gave that example of 2 potters whose productivity was different. But I'm going to return to the point made earlier in the text in chapter 7 about economic rent. We saw that highly productive workers, and in that example from chapter 7, it was this fantastic chef who was just so much better than everybody else that chef brought a lot more revenue to the company that employed that person. Well, we see this. People's earnings are closely tied to their productivity, and we saw that bidding process for hiring the more productive workers bid up the wages of those more productive workers. So at a very basic level, earning power is tied to productivity. And we see this for the economy wide. Wage growth mirrors, real wage growth mirrors productivity growth economy wide quite closely, decade on decade, with some exceptions perhaps. But it's a pretty tight relationship. We see that at the individual level too. Let's formalize this understanding from the point of view of a company thinking about hiring workers, and I'm just going to go through that example in the text. Adirondack Woodworking Company. So here I've got a picture of a wood shop. This firm has a bunch of equipment here. We see all these pieces of equipment whose names I don't even know. I'm not a woodworker by any stretch. And then with that floor space and machinery that this company has, the company employs workers to produce output. And in our simple example, we just have a relationship between workers hired and the output of kitchen cutting boards. And we assume in this simplified case that all workers are the same. But remember that because of the fact that we're adding workers in the presence of fixed plant space and equipment, that productivity, marginal productivity falls as we add more workers. The output that results from the last worker hired is falling. And remember that the benefit side of hiring a worker is the output that results from that worker that the firm can then sell in goods markets. So factor markets sort of are have this dependency on goods markets. If a firm couldn't sell its product in a market, in a goods market, there wouldn't be any demand for workers. All right, well, let's think through the question. We had some information here, in particular, the wage rate given in this example. This is example 12.1, I believe. The wage rate was equal to $350 per week. And we have a situation where we know how many cutting boards results from hiring one more worker for 1 worker a week, 2 worker a week, 3, etc. But we got to pay the wages in dollars, so we want to be able to compare apples to apples, not apples to oranges. So we actually multiply the marginal product by the price. Where Adirondack sells its output in a competitive market. We learned in reading that example. So we multiply the marginal product by price, which is constant at $20 per cutting board. This firm can sell all at once at $20. That's because it's a competitive firm. Anyway, and we end up with the monetary gain associated with hiring each worker. Well, now we're, remember I mentioned, well, I probably mentioned a zillion times that we apply this cost-benefit type of reasoning over and over again in microeconomics. The challenge is to convert our information into a form where we can apply that reasoning. And now we've done it. So remember that as long as the benefits of hiring one more worker, that's this value marginal product, are greater than the cost of hiring one more worker for a week, we're looking at hiring workers 1 week at a time, 1 worker week at a time, as long as the benefits of hiring another week of labor exceed the costs, we'll hire 1 more week. So do we hire that first worker? Yes, 600 is greater than 350. Second worker, yeah, 500 is greater than 350. Third worker, you bet, 420 is greater than 350. Even the fourth worker produces $360 in value marginal product, so that makes good sense to hire that worker. Do we hire the fifth? Absolutely not. 280 is less than $350 a week. We're not going to pay out $350 to get 280. That would put us out of business real fast. This kind of reasoning gets us to the conclusion that for a competitive firm, my phone's ringing, I apologize, the labor demand curve, since the firm's going to keep hiring just up to the point where value marginal product is equal to wage rate, this value marginal product is the competitive firm's labor demand function. And then the next couple of concept checks ask you to think through a couple of variations on that problem. One is, I'm going to have to go to a smaller pen if I'm going to add this information. One of the concept checks asks you to ask what would happen to the firm's labor demand and how many workers hired at $350 a week if the price of the product went up to 26. I'm going to just make that calculation. I'm going to give myself a little room here by erasing that little box that I just erased. And I'll erase the $20 because we already went through that case. And now I'm going to create a new column that we'll creatively call VMP prime. And that's also dollars per week, but it's going to be P equals 26. And I've calculated these values before. I'm trying to write an equal sign, not a very pretty equal sign, but you get the idea. So our value marginal product function, if the price of the cutting boards rises to 26, our new value marginal product function is 780 at 1 worker, 650 at 2, 546 at 3, 468. That fourth worker produces $468 worth of gain now. And finally, that fifth worker produces output that we can turn around and sell, that Adirondack can turn around and sell for $364. So now, under that new price, the firm's labor demand goes up, and indeed at a wage rate of $350 a week, its hiring goes up from 4 workers a week to 5. And then concept check $12 asks you how many workers should Adirondack hire if the wage rate falls to $275. And let's see, we go back. This is example 12.2, and if you go back to the case where the price, let's change color. If we go back to the case where the price was $20 a week, otherwise it's not much of a problem. If we go back to that base case, and now wages are equal to $275 per week, then we have a case where even at these original productivity, value marginal products rather, that now at a wage of $275, it would make sense to hire that fifth worker in that case as well. Well, formalizing this, we have a situation where the firm's labor demand curve, I'm just going to go with the blue pen, is equal to the value marginal product. Since we're just multiplying this marginal product function by a scalar, the price of the output, we have a downward sloping function because marginal product is downward sloping in the short run, and adding labor in the presence of fixed factors. So this is called the value marginal product function, value marginal product of labor, and that's equal to the firm's labor demand curve. On the x-axis, we have worker per week, and worker weeks per week, I could have said, and in the wage rate, we have dollars per worker week. I'm just going to write week. So in that previous example, we had, if we had the numbers that we started with, the wage rate was $350 a week, and we initially had an output, a labor hiring level of 4. When the price of the product went up, I'm going to change colors here. When the price of the product went up, we saw this increase in labor demand, value marginal product prime is what we called it, and hiring went up to 5. And then, of course, when we were in the case, I'm going to change yet to another color. Let's make it bright yellow this time. When we were, again, talking about this base case, and wage rate fell to $275, not drawn to scale, we hired that fifth worker as well. So that's labor demand, and then we're going to move on to labor supply in the next screencast. And here I violated my own screencast tip. Keep it 6 minutes or less. I've doubled that. I apologize.